Hello, you are welcome to another video. I would like to recommend that before you watch this video, I will recommend the initial video that I did. And in the initial video, I proved that the volume of solid revolution is given by the integration of pi y squared dx, because that is the formula we are going to be using to answer this question. Alright, so in this question we have to prove that the volume of a sphere is equal to 4 over 3 by r cubed without integrating the total surface area, because normally you could find the formula for the volume of any shape by simply integrating this surface area formula. So but we are not going to do that for this question. Alright, by using this formula to answer the question, recall that the formula for equation of a circle is given by x squared plus y squared is equals to r squared. So we are going to be needing this formula, and the reason being that we are going to be considering a Cartesian plane, that is our y and our x coordinates, y and x. And let's assume we have a semicircle in this Cartesian plane with a boundary of minus r to plus r, indicating the radius of the circle. That is, when this semicircle makes a 360 degrees revolution, we are going to be having a sphere. When it makes a 360 degree revolution, we are going to be having a sphere. So then we are going to also be needing a formula for our y, just this equation in terms of y, and it's going to be y is equals to r squared minus x squared, then the square root of everything. That's going to be the formula for y. Then we are now going to substitute the value of y into this formula, and that will give us the volume as the integration, but this time around we have our limit to be minus r to plus r. That is, when this semicircle makes a 360 degrees revolution, then pi, then substitute the value of y now, which is equal to the square root of r squared minus x squared. Then we are going to find the square of everything, then the x. So this formula has been transformed to this form. So what we need to do now is just to integrate. That's all we need to do in order to get our formula. By integration, this is going to be, but first of all, you have to consider that this square root is going to cancel this square. The square root will cancel the square. And this formula will be further transformed to minus r to plus r, that is pi bracket r squared minus x squared beta x. So now by integration, this will be being as a definite integration. In this case here, our r is a constant while we are integrating in terms of x. So by integrating r squared is going to give us, then we can bring this pi outside of the whole thing, and this is going to be x r squared, then minus x raised to power 3 over 3. Then we write our boundary, which is from minus r to plus r. So we are done with our integration, but we are going to get our formula. So what we need to do now is just to substitute the boundaries. That is, wherever you see x, you put r and minus r respectively. Then this will give us p, then pi. Then first of all, let us put our positive value of r, that is for x in this case here, that is going to be r into bracket r squared minus r cubed over 3 minus the lower limit of the expression, that is equally equal to pi, that is minus r into bracket r squared then minus r is power 3 over 3. Then we close the bracket. Then going further with this will be, so this will be pi into bracket, this will be r raised power 3, then minus r raised power 3 over 3. Close the bracket, then minus pi, that is, this will simply be minus r raised power 3, then minus, remember that this minus will cancel, it will turn to plus, plus r raised power 3 over 3. Close the bracket. Then you can simply factorize out your pi. Then your volume will be pi into bracket, solving this particular one, it will be r cubed minus r cubed over 3, and that will simply be 2 over 3. 2 over 3 r cubed minus pi, then this will be minus 2 over 3 r cubed. Okay, now let's factorize. Actually factorize earlier, but I still wrote this r, this pi. So this time around, let's factorize completely. So this will be pi into bracket 2 over 3 r cubed minus 2 over 3 r cubed. This will give us v is equals to pi into bracket 2 over 3 r cubed plus 2 over 3 r cubed. Close the bracket. By the time you add these two fractions, you are going to get pi 4 over 3 r cubed, which conventionally is written as 4 over 3 pi r cubed. So that is the way of getting the volume of a sphere without needing to integrate the area of the sphere, which is given as 4 pi r squared. What you need is just the equation of that particular line. Then you slot it into the formula for volume of solid revolution. The volume of solid revolution is simply given in the previous video. So that is a solution to the question. I would like to see your comments for any questions or any suggestions. Thank you.